In this video I'm going to show you how to do AQA A-Level Maths from June 2018, Paper 1, Question 13. My name is Sunil Tanna. I'm an author and tutor. I'm available for one-to-one tuition both online and in person. I live in Buckinghamshire, England. The company is designing a logo. The logo is a circle of radius 4 inches with an inscribed rectangle. The rectangle must be as large as possible. The company models the logo as an XY plane as shown in the diagram. Use calculus to find the maximum area of the rectangle and justify your answer. Okay, so if we said this point here is XY, this distance will be X and the full width of the rectangular part will be 2X. Likewise, this distance here will be Y and the full height will be 2y. So using that information we can say the area of the rectangular part would be 2x times 2y or 4xy. We also know that we have a circle centered on the origin, and we know that the formula for such a circle is x squared plus y squared is equal to the radius squared, in this case 4 squared or 16. Now if we look at that, what we can do is we can derive an equation for a in terms of either just x or y, which will allow us to use calculus to find the stationary point, which will be eventually will be the maximum. So what we need to do is use the right-hand side equation to make y the subject. So we can see that y squared is 16 minus x squared, so y is the square root of 16 minus x squared. And if we substitute that into our equation for a, we'll have a is 4x times the square root of 16 minus x squared, which we could also write as 4x times 16 minus x squared to the power a half. Now we can find a stationary point. Now this could be a maximum, it could be a minimum, so later on we will need to justify that, but we'll leave that for a moment. So we want to find the stationary point. So stationary point is when dA dx is equal to 0. And we can find the dA dx by differentiating this expression here. Now it's two parts multiplied together, so we're using the product rule. If we differentiate the first part, which would usually be the u and the v, that would become 4, and leave the second part alone will be 16 minus x squared to a half. And now we do it the other way around, so we will now have 4x. Now we're using the chain rule for this, so you bring the power in front, which will be a half, differentiate the inside, which will be minus 2x, and then reduce the power by 1, 16 minus x squared to the minus a half, which you can simplify a little bit if you want. You could think of this as being 4 times 16 minus x squared, and then this will be 4 times a half is 2, times minus 2 is minus 4, x times x is minus 4x squared, and then power of minus half means divided by that expression, so divided by 16 minus x squared to the half. Okay, now if we now what we want to now do is multiply both sides by 16 minus, this should also have a half here, by 16 minus x squared to the half, yeah? So, and remember this is equal to 0. So if we multiply 0 by this, the left-hand side will remain 0. 16 minus x squared to the half times 16 minus x squared to the half just becomes 4 times 16 minus x squared, and then we've also got a minus 4x squared here. And if we expand out the bracket, we can get minus 4x squared, another minus 4x squared, and 4 times 16. So we will have 0 is equal to 64 minus 8x squared. And then if we divide by 8 and bring the 8x squared to the other side, or whichever order you want to do it in, you'll have that x squared is equal to 8. So x is equal to the square root of 8, which some people might prefer to write as 2 root 2. Okay, so at the stationary point, the area is given by this formula. 4x, so that will be 4 times root 8 times the square root of 16 minus x squared. So 16 minus square root of 8 squared is 8. So 16 minus 8. So you can see that is actually 4 times root 8 times root 8. Root 8 times root 8 is 8, and then 4 times 8 is 32. So, but this could be a minimum or a maximum. So we'll put here, but this may be a min or maximum. The reason we don't know which is all we know is that the gradient at that point is 0. It could be the smallest possible rectangular area or the largest possible rectangular area. So we now need to do some justification to prove it is a minimum or maximum. Now, I'll start a new page, but what I'll do is I'll copy over the formula that we had for dA dx. So in the previous part of the question, we had dA dx is equal to 4 times 16 minus x squared to the half minus 4x squared over 16 minus x squared all to the half. Okay, so how can we prove it's a minimum or maximum? There's two typical ways we can do that. Quite often what we do is do the second derivative, and if the second derivative at that point turns out to be positive, it will be a minimum. If the second derivative at that point is a negative value, it would be a maximum. Now, doing the second derivative here is kind of awkward because it's we've got these two expressions at the beginning, we've got this quotient, and so on. So the other alternative is to test the gradient just before the stationary point and just afterwards the stationary point. Because if it was a maximum, what we'd see is if that's the stationary point, the gradient would be positive before the stationary point and negative after the stationary point because the curve would go down. If it was a minimum, the gradient would be negative before the stationary point and the gradient would be positive after the stationary point. So we can do our tests. So to the left of stationary point, we can use x is equal to the square root of 8, maybe minus 0.1. And if we put that into dA dx, we'll find that dA dx is equal to, at that point, 0.15198. You can use our calculator to put that in. And to the right of the stationary point, x is equal to maybe square root of 8 plus 0.1. So dA dx at that point, again we use our calculator to work this out. It comes out to about minus 1.69. So you can see that the curve is going up before the stationary point. It's got a positive gradient. Then it becomes 0 at the stationary point. And then after the stationary point, it goes down again. So this tells us, therefore, it's a maximum. So max area, remember from the previous part, we found that the stationary point was when A is equal to 32. And that completes question 13.